So in a circle, I've already said this, but now it's actually written as a statement. The length of the diameter is twice the length of the radius. So your diameter is going to be 2 times your radius. And something else that's interesting about circles is that any radius that is perpendicular to a chord. So here we'll have our center O, and let's say here's our chord. Any radius that is perpendicular to a chord will bisect that chord. So that's something that we'll probably use when we're talking about measurements. A radius that's perpendicular to a chord bisects the chord. Bisect, of course, meaning creating two congruent segments. So now let's talk about the sum of the measures. Most people know that circles have 360 degrees, contain 360 degrees. So central angle BOC is a 90-degree angle. So I would say the measure of angle BOC is 90 degrees. And that is a central angle. So the intercepted arc, the measure of arc BC, will also be 90 degrees. In a circle, the degree measure of the central angle is equal to the degree measure of the intercepted arc. So if we look at the circle down here, we know that the measure of arc BC is going to be 90 degrees because that's a right angle. We know that the measure of arc CDA is going to be 180 degrees because its intercepted arc is a diameter. And we know that the measure of arc AB is also 90 degrees. So all of the central angles will add up to 360 degrees, and all of the intercepted arcs will also add up to 360 degrees. And that's what it says on the top of the next page, even though they started at AB. Arc AB was 90 degrees, arc BCD was 180 degrees, and then arc DA was also 90 degrees. That gave me my 360 degree circle in arc measurements. So in general, the sum of the measures of consecutive arcs will form a circle. So that's the addition postulate. Do you remember we added 2 line segments? And then we added 2 angles. Well, now we're adding arcs. And this would be adding the length of the segment, the measure of the angle, or the measure of the arcs. All right, so in this figure, let's say that the measure of angle XYZ, which is a central angle, is 76 degrees. So that would mean the measure of arc XZ would also be 76 degrees. Now here's the thing. If you're looking across 2 different circles, here I have a circle with an arc measure of 40 degrees. So the measure of arc RS is 40 degrees. And here I have a circle with the measure of arc VT is also 40 degrees. Are these arcs congruent? Their measures are the same, But the answer is no. The arcs are not congruent. They are the same shape, but you know what? They're not the same size. Really, their lengths are not the same. So in a single circle, or if I have congruent circles, what are congruent circles? Same radius. That's the definition of congruent circles. Then congruent arcs are equal measure. So here if I have circle A and here I have circle B, if that radius is 5 and that radius is 5, and that's 20 degrees, and that's 20 degrees, well, the measure of this arc will be 20, and the measure of this arc will also be 20. And these two arcs will be congruent because the diameters are the same length. These are congruent circles, so the arc measures are the same. To clarify that, let's look at these concentric circles. Obviously, the central angle is going to have the same measure, so the measure of arc AB is going to equal the measure of arc CD. So their intercepted arcs have the same measure, but their radii are not the same. So although the measures are the same, we would not say that the arcs are congruent. We would say no, they're not congruent. And if you were able to measure a linear arc with some sort of measuring device, which, you know, I guess if we had a small enough one, we could use a protractor, they would not be the same length. All right, so we're going to use the fact that a circle is 360 degrees to try to find the indicated measurements. So the measure of arc AB, well, if the central angle is 105, the arc is also going to be 105 degrees. The measure of arc BC. If the intercepted angle is 70, the measure of the arc is going to be 70. How about the measure of arc BD? The central angle is 70 plus 35. This is a 105 degree angle, which means we have a 105 degree intercepted arc. Okay, how about the angle AOD? AOD. Well, we know what will be left here. What is the measure of angle AOD? We know that the sum of all the angles of a circle are going to equal 360. So what is 105 plus 70 plus 35? That's going to be 210. And if 360 is the total circle, let's subtract out our 210, and we're left with 150. So the measure of this angle, AOD, must be a 150 degree angle. But how do we know, now we're asked here, what's the measure of arc AE? How do we know the measure of this angle versus this angle? Well, here in our description, we are told that OE bisects AOD. We are told that this segment bisects these two angles. So I'm going to put the single arcs there saying that they are congruent. Well, if together they equal 150, 150 divided by 2, well, they each must be 75 degrees. So if this is a 75 degree angle, this is a 75 degree arc. So is this one, by the way. What is the measure of angle ACE? A through the point C and down to the point E. I need the measure of this arc. All right, so if this one's 75, this one's 75. So how am I going to find that measure? I can either do 360 minus 75, or I can add them all up. So let's see, we have 105 plus 70 plus 35 plus 75. And when we add all those up, we get 285. So this is a 285 degree angle, so this is a 285 degree arc measure. And is arc AE congruent with arc ED? Well, they're both 75 degrees and they're both in a circle with the same radius, so yes, they are congruent. And what is the measure of the reflex angle that intercepts ABCD? ABCD. Let's grab another color here. ABCD. It's going to stop here. What is this angle? That's going to be 105 plus 70 plus 35. That's a 210 degree angle.